we want these bunches to pass through each other. 10 to the 11 protons, 10 to the 11 protons. In this so much, very, very small sausage, thickness of my hair, length of my finger, okay? But because to the particles inside here, that is an enormous volume. It's mainly empty space. And so most of the particles pass straight through. We only manage to get 10 to interact. But we're not interested in the protons. We're interested in the constituent sort of contents of the proton, which are quarks, and gluons, which hold the quarks together. In the proton, we have 3 quarks. If I tell you how big a quark is, it won't mean anything to you. A quark is 10 to the minus 19 of a meter. That is 1 over 1 and 16 zeros. That is the size of a quark. We're made of quarks. We're mainly empty space. If you removed all the empty space in any of you, what would be left would be a speck that if you had a magnifying glass, you might be able to see it. That was written in the weekly bulletin by the CERN director about 4 years ago. I cut it out. I thought, that is interesting. And we are trying to get these quarks to interact. It's impossible. And that's why we need so many of them. 10 to the 11, 10 to the 11, only 10 interact. So the thing we want to do is to get a quark to come together and disappear. We want that total energy. And that's the energy we needed to make the Higgs boson. Now if you consider that process, that is equivalent to 2 mosquitoes colliding. Big deal, big deal. But you reduce a mosquito to the size of a quark, and the energy density is so much. There's so much energy that you have in one point. That's why we thought, and we might, we maybe have created a black hole. You may probably remember that when we were trying to start the machine. But even if we did, the theorists had to put out a case. There were people who were trying to get legal legal laws passed that we couldn't start the machine. And the theorists had to explain, we might create black holes, but you're creating them in such a small volume that nothing will happen, because black holes need gravity, they need mass, so they would evaporate into nothing. So, yeah, we've survived. We haven't sucked everybody into CERN. Okay, what's the value?
0.
0, we're all safe. We haven't got any radiation. Okay, any questions? Lots of fun,
brilliant. We had a question.
Yeah.
Like when the machine is running and the helium system is in place, what's the ambient temperature?
What is the
ambient temperature?
Outside of the...
no. It must be ambient.
Okay.
If it was cold, that means we were losing lots of energy.
Yeah, but there is some loss, right?
Very little.
Okay.
If you touch that blue magnet, it's room temperature.
Oh, okay.
How do you make that? The vacuum in there. This